experimental design.
Please do not collect this.
For your article? Yeah, I'll collect it in a second. I forgot. As a matter of fact, catch your articles up. Let's just do that now. Now, there's 3 elements that help define or limit your experiment. One of them is control. You need to have complete control over your experiment. Just as you're doing science, you basically want to change one variable at a time. If you change more than one variable, you might find that you have a confounding variable. A confounding variable occurs in this case. Say I'm doing a science project and I want to test the soils, different types of soils. You probably did one of these when you were younger. You're growing seeds, sunflower seeds. You have 3 kinds of soils. You have sand, you have dirt from outside, and you have potting soil. 3 soils. And you plant your seeds in them. And you put all your pots in front of the window. Everybody says they're the same. Now, what happens is you can control this because everything is working in the same environment and your soil is the difference. But if I took those 3 pots that I did and I put one by the window, one by the door, and one by the corner, I have another variable here. It's the amount of light that it's getting. So that's a confounding variable. It's not only going to depend on the soil, it's now going to depend on the light. So a confounding variable can throw the effect of yours off a little bit. So you want to avoid your confounding variables in your study. If you're going to measure someone's heart rate because you're giving them an increase of caffeine in their day, you want to make sure that their caffeine is limited to a certain amount that you put in, not that they drink excess or they don't drink enough caffeine. You're going to have to give them the level of caffeine that they need to drink so that you can see their heart rates. A placebo effect. We talked about this the other day. A placebo effect is very common. It's like a psychological thing. If you're giving me an energy drink and you're telling me that I'm going to be more energized throughout my day, I'm going to have a lot more energy, I'm not going to hit that lull around 3 o'clock in the afternoon. At 3 o'clock in the afternoon, I'm going to feel pretty good because I think I'm drinking this energy drink, when in fact, I'm not. I'm just drinking a colored water, a solution that has nothing to do with my energy level. But because I'm thinking this, I'm going to hit 3 o'clock and say, wow, I still have a lot of energy. So a placebo effect is more like a psychological effect when a subject reacts to a placebo but thinks they had the real thing. Blinding, we talked about this too. You of course do not want your subjects to know because then it's biased. If you tell me you're giving me the energy drink and you tell someone from the other group they're not having the energy drink, of course I'm going to feel all energized because I know I'm having it. They're going to be like, oh, it's 3 o'clock, I can't get through my day, because they didn't have anything. So you want to keep this blind. You don't want your participants to know if they're the treatment or the control group. You don't want them to know. A double blind is the person giving you the drinks doesn't know either. They're given something and they hand all this, the bottle A, to this control group. They hand bottle B to the treatment group. They don't know if bottle A is the high energy drink or bottle B is. Not until the end. Not until the end. You don't want them to have bias either. You don't want them to be like, oh, here's your drink. This is really good. Versus here, drink this. You don't want any bias on the part of the person running the experiment or the person, taking part in the experiment. And then at the end, you have to tell them that bottle B, by the way, was your treatment. Let's see how that group performed. Okay? So we see this in blinding. Randomization. Randomization is just constantly making sure everything's randomly assigned. When you have your participants, you have a random way, and we're going to talk about how to set those up in a minute. You have a random way to do this. And your completely randomized designs, your subjects are assigned to a different treatment group rather than through your random selection, rather than you assigning them. You want them, even if you send them to different groups, you want them at randomly assigned. You don't want to take part in that because you don't want any personal bias in there at all. Now your blocks, you could take a group of people and you can block them. Say I have 100 people participating in this study. I separated them into 50 and 50. My control group, my treatment group. 50 is still a lot to manage. So maybe I want to make, in this group, 2 groups of 25. And then in the other one, 2 groups of 25. I want to block them inside their groups. I really don't want to block male and female because you expect male and female to be different. Maybe I want to take ages, certain things, and I always want them taken from the same population. So you have to be careful on how you set this up. Your matched pairs, sometimes you can pair your subjects according to how similar they are. Right? And your replication just means you're going to repeat this a number of times, just as you would a science experiment. You want to make sure that your results are good. In probability, we have theoretical versus experimental. Theoretical has been done over and over and over. Experimental has been done many times through your experiment, and your experiment usually comes a little closer to your theoretical with the more that you do. Your sample size is important. That's why you replicate. You want a larger sample size. If you have a sample size too small, if I only choose 5 people to test, that's a little bit too small. I need to go with, a larger group. I don't know if those 5 are true representatives of my population. All aspects of your population. So let's take a look at example 2. This way you can kind of see what we're doing here. It's on page 20. A company wants to test the effectiveness of a new gum developed to help people quit smoking. You need to identify a potential problem with the given experimental design, and you need to suggest ways that you can improve that. So the first one says, we have 10 adults. The company identifies 10 adults who are heavy smokers. 5 of those subjects are given the new gum, and the other 5, are given a placebo. After 2 months, the subjects are evaluated, and it is found that the 5 who were using the gum quit smoking. Okay? Now, you have to do this after a certain amount of time. 2 months is not a bad amount of time to go through your subjects. But what other problems could there be here? What other problems can you see in this design? Oh, it's not a lot of people. You only have 5. I'm not really sure how many people are in this whole company, but you got to probably pick more than 10 people to work in your groups. God bless you. Because when you take those 10 people, you're doing 5 and 5. You want to make sure that those are true representing your population the best way you can. So the only thing with this is they don't really have a lot of participants in their study. Maybe, in fact, they didn't have a lot of smokers. That could be too. Sometimes you can't get a larger sample size because they're just not available. Okay, number 2. The company identifies 1,000 adults who are heavy smokers. The subjects are divided into blocks according to gender. Females are given the new gum, and males are given the placebo. After 2 months, a significant number of females have quit smoking. Is this a good design? No, why? A significant. Yeah, we don't know how many, but they're probably saying a good amount of them did quit smoking. They did better than the males. Yes. Right. It's different genders. It's exactly right. When you make your groups, you want them very similar. Males and females are very different. So you want to make similar groups. Maybe you want to divide them into an equal amount of males, equal amount of females, and then subdivide underneath that. But not when you're separated into your placebo group and your control group, your treatment group. So these are things we have to look at, that we have a large enough sample, that we have a good representation, and you want to make sure that your groups are similar in characteristics. Retry it too and see what you come up with. Good design? No? Yes? Okay, do you like the fact that we used 240 people? Okay, I like that fact. They're heavy smokers. We randomly assigned them. That was good. And not only did we give them the gum, but we also gave them a DVD. And after 4 months, most of them quit smoking. What was it? What was it because of? The DVD or the gum? Hmm?
You don't know which one?
You don't know. So what is this called when we throw in something else? When we throw in another variable? It could be a confounding variable. I'm not really sure which one had a better effect. Maybe the DVD did, maybe the gum did. Okay? They gave their subjects gum as well as a DVD. You really can't do two things at the same time. Okay? So that was the problem with this guy. You want to make sure that you control what you're giving them. Okay, sampling techniques. Now we get to the good part. How do I make this sample? What kind of ways can I choose the people for my sample? Remember, always is the word random. It's always random sampling. But random samples have their own little way to do this too. Excuse me. Remember that your census is the entire population. Your sampling is just your part from your sample. And your sampling error occurs when there's a difference between the results that you get from your sample versus the results that you would get from your population. So you want to keep this as small as possible. You want your sample to be a good representation of your population. Okay? Now, one of the ways which we can set up a good sample is your random sample. Your random sample is done through a certain method. Usually a random table generator, your calculators generate random numbers. Rather than opening a phone book and picking this and picking this, you may kind of be inclined to always go to the middle. You never go to the corners. That's still a little bit of bias in there. One of the ways we do this is from a table. Now there's a table in the back of your book, and I'm pretty sure it's the first blue page, the first blue one that we saved. Nope. No. Let me find your table. Your table is on page A7. A7. I took the first few rows of this. Now, I have 30 people in this class. I need to randomly select 10 people. So I go around the room and I give you a number. 1, 2, 3, 4, 5, 6, 7, 8. I give you all the way up to 30. I need to randomly take 10 people. I don't want to say I'll take 2 from this row, I'll take 2. There's my bias. So I refer to my table. and you can start it at any point in your table. And since 30 only gives me 2 digits, from 01 to 30, I section this every 2. I just go across the row and I section every 2. And so forth. See it? Okay, now I start. Do I have a number 92 in my 1 to 30? No. Do I have a number 63? No. Do I have a number 7? Oh, I'll take that person. Do I have a number 82? 40? Nope. 19? Oh, I'll take 19. 26? Yep, I'll take 26. And I keep on doing this until I get my 10 people. Completely random. I don't know who they are. I just use my table. I can start it at any point. I can work backwards off my table. Whichever way you choose. You have a random number generator on your calculators too that will generate random numbers. You can tell it to go from 1 to 30 and give me 10 numbers. And it will randomly go through a table and pull out your 10 numbers. Okay, we're going to do that in a minute. In fact, I think your book tells you how to do it. If you look on page 21, there's a random generator. You'll tell it from 1 to 30, and you'll say, I want 10. And it'll pick out 10 numbers from a random table. Now, the only thing I found with your calculators, I don't know if this one does it with the new software, but the old ones, the 83s, used to reset at the same point on the table. So everybody was getting the same amount of numbers. I'm hoping this one doesn't, but the old ones used to reset. So this is a nice way to do this. The difference between a random sample and a simple random sample is your random sample says every person has an equal chance of being selected. In your simple random sample, you get a sample in which every possible sample of the same size. I'm going to make different samples of the same size. If I want 10, random sample. If I want samples of size 10, that's my simple random sample. If you just catch the random sample part, I'm happy with that. It has to have some kind of way to generate these numbers. Through a table, through your computer, through something, through some algorithm to generate this. Another way we do this is a stratify. And I put some of these here for you. I like the pictures. Your random sample, I showed you the table and the random number generator. Your stratified sample, your stratified says this. I need to pick 20 people from this high school. Well, let me pick 200. 200 people from this high school to ask about a survey about your lockers. Now, do I just want to ask seniors or sophomores or freshmen? I want to ask everybody, right? So I take a stratified approach. God bless you. There's 4 levels. Freshman, sophomore, junior, senior. Dan, they're over here. There's 4 levels. I want 200. I want 50 from each level. That's called a stratified sample. Every group is represented equally. So I'm going to take 50 freshmen, 50 sophomores, 50 juniors, 50 seniors. And that's a stratified sample. It reminds me of a stratified rock. Remember when you first take earth science? I don't know if you still call it earth science. Okay, when you first take earth science, you learn about all the sedimentary rocks and the hard rocks and whatnot, and you learned about a stratified rock. It has different layers, from the hardest to the softest, because they're compressed. So it's kind of like this. It's different layers. Everybody's layers have to be represented. A cluster sample is different. A cluster sample says, I want all the freshmen. So I have to sample every freshman. Usually clusters go by zip codes, certain areas. I want to take all the Midwest. I want to take all the East Coast. like a certain area, and you have to sample everybody in that area. Systematic, we talked about systematic, that was like your gym class. You want to make teams. You want to make a basketball team for your gym class. You don't want all your basketball players to pick each other, so you have them line up and you count off 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All the ones here, all the twos, all the threes, all the fours. Systematic. I like this because it kind of was a nice visual to show you that. And your last one, which you want to try to avoid, is your convenience sample. Your convenience sample is where you ask your friends. You have to do this survey. I gave you a survey to do, and I wanted you to get 10 responses. So you're sitting at lunch and you say, can you just answer these questions if I show them to you? I just have to get 10 responses. You ask all your friends. Chances are they're your friends because they have similar likes as you, similar, characteristics as you, so it kind of groups you as friends. So that's a totally biased way to sample. So you want to avoid your convenience sample. Okay? So let's take a look at this. Sample 3. There are 731 students currently enrolled in statistics in your school. You wish to form a sample of 8 students to answer some survey questions. You want to sample them at random. Now, you're going to refer to table on A7. You're going to start at the first one, and you're going to find me the number of your first 8 students. Monty, come on, A7. I want the first 8 students. You have a table on A7. I want your first 8 students. Out of 731 students, I want the number of the 8 students that you're selecting. You should all get the same. So everybody needs to work on this. I'll figure it out. We did one together before. You figured this one out. Yeah, that just really doesn't help you any. It's like data for like some of the things in there, and they use a lot of like Minitab, and they use a lot of software that we don't use here. Guys, excuse me. This is individual. Open your books to page A7 in the back, which you should have looked at when I asked you before to look at it, and find me the numbers of the first 8 random people that you're selecting. When I did this before, did anybody hear what I was doing? Yeah?
Yeah.
Yes.